material, which is three-phase sinusoidal steady-state power, and there's a homework assignment due, homework number 3, at the end of this unit. Exam 2 will occur after Unit 5. In this video, what I want to talk about are these different ways of describing voltages and currents that exist in a three-phase system. And we will talk about 2 voltage types and 2 current types. And one of those will be phase voltage, and that depends on the connection. The other side to that is a phase current, and that also depends on whether you are in a Y or delta connection or configuration for the source or the load. And that's what I want you to remember. Anytime somebody tells you phase, then you need to be alert to how that particular load or source has been connected. Is it a Y connection or a delta connection? And that will impact what we are calling the phase voltage or the phase current in those situations. The other 2 quantities will be the line voltage, and that's always going to be defined the same way, and the line current, which will always be defined the same way. The line voltage is the voltage difference between 2 transmission line terminals, either at the source side or the load side, and the line current is the current flowing in a transmission line. Let's now see if we can make the distinction or make it clear what we mean by these 4 different descriptions for voltage and current. Let's start with phase voltage. And as I said before, phase, anytime you hear phase, then you need to worry about the connection. So this is the phase voltage is defined to be the voltage across a particular phase impedance, or if we're dealing with a source, the phase of that particular source. Let's look at the difference between a Y-connected load and a delta-connected load. The phase voltage, again, is defined to be the voltage across a particular phase impedance. The A phase impedance in the Y connection is then going to determine the phase voltage. What is the voltage drop from the A terminal to the neutral terminal in the Y connected load? Meaning the phase voltage is now V sub AN in a Y connected load. Contrast that with a delta connected load. The phase voltage again is associated with the voltage dropped across a particular phase impedance. The A phase impedance, just to make things consistent, is Z sub A, but in a delta connected load, the phase voltage will actually be between terminal A and terminal B in a delta connected load, so that now in a delta connected load, the phase voltage is actually V sub AB. And I hope that you can see just by the notation that the phase voltage for the Y connected load is not the same as the phase voltage for the delta connected load. That should be clear, I hope. The line voltage is always, it doesn't change. So now when you hear line voltage, now you can sort of just think, oh, line is really an abbreviation for transmission line to transmission line, and that will be shortened to line or just line. But the line voltage is always the voltage between 2 line terminals, or the line-to-line voltage. In a Y-connected load, the line voltage is V sub AB. It's from the A terminal to the B terminal. The line voltage in a delta-connected load is from the A terminal to the B terminal. It too is V sub AB. The line voltage then is independent of the I mean, its magnitude will depend on what's going on in the circuit, but the definition of the line voltage doesn't depend on how the load, or the source for that matter, is interconnected. It's always between transmission line to transmission line. When you hear line, you can then think of, oh, this is always transmission line to transmission line, whether that's at the terminals of the generator or source or at the terminals of the load. That's now different. The line voltage is a different concept than the phase voltage, but I think you can see that the phase voltage for a delta connected load is the same as the line voltage in a delta connected load. For Y connected loads, that's not true. The line voltage is V sub AB, and that's not the same as the phase voltage in a Y connected load. And that's the distinction you need to be clear on. We can have the same kind of thought process when we're dealing with phase current and line current. Again, phase current, worry about the connection. This is the current passing through a particular phase impedance if we are dealing with the load, or a phase source if we are dealing with the generator side of the problem. So now let's look at the phase current. It's defined to be the current passing through a particular phase impedance. For a Y-connected load, the phase impedance for the A phase is Z sub A. And for that reason, then, the phase current is I sub little a capital A for a Y-connected load. In a delta-connected load, the phase impedance for the A phase is Z sub A, but now the current flowing through that particular phase is I sub AB. And I hope from just the notational way of writing these, the phase current in the Y load, which is I sub AA, is not the same as the phase current in a delta load. The phase current depends on how the load is connected, whether it's Y connected or delta connected. Contrast that with the line current. Now when you hear line, you can think, oh, these are transmission lines. This is always the current flowing through a particular transmission line, or a phase of a particular transmission line. Thus, if we look at the Y connection, what's the transmission line current? Well, that's I sub AA. That's the current through the transmission line from the generator side, little a, to the load side, capital A. What's the line current for a delta load? Well, again, that's exactly the same. It's the current through the transmission line in the A phase, which here is the A phase transmission line. It's from the generator side, little a, to the load side, capital A. And here then, it does not matter. The line current is always I sub AA, whether you have a Y connection or a delta connection. It's only when you start talking about phase variables, phase current and phase voltage, that you have to worry about the connection. And here, I hope you can see that the phase current is the same as the line current in a Y configuration. In a delta configuration, that is not the case. The line current is definitely not equal to the phase current for a delta connected load. That's what you need to be clear on. The distinction between phase, oh, that depends on the connection, and line, oh, that's dealing with transmission lines. And hopefully that will make things clear when we start, or as you're working through all of these problems and somebody mentions something about line current or phase current, you have to be clear on what that means or how that translates into your particular problem.